All right, we're back. Let me pull up. So we're continuing on PyTorch Lightning, baby. PyTorch Lightning. It's tricky learning something new, but I like it so far. It's nice. So we'll go to, actually we'll do this. Tmux, attach, lightning. Let's go. This is where we finished off. And again, what we're trying to do now is to convert a variational autoencoder to PyTorch Lightning. So we have bare bones PyTorch implementation, and now we're trying to convert it. And we're trying to learn stuff like, well, how do you, like right now, we've set up, let's see what we've done. We've set up the model. Let me bring up the chat if there's anyone asking any questions. Yeah. Hey, Amit, what's up? Yeah, I'm a fan so far. I like it. I think it's going to be a nice tool once I get more comfortable with it. All right, cool. So basically we converted the VAE encoder and decoder part. I guess this is the encoder and this is the decoder part. We set it up, encode, decode. We set up a forward step. This means that we can run on our training step, validation and test step. We can run it like this, where we do okay, now we actually did self.forward. I think it's possible to just do self, but yeah, that works. So we do self.forward and we run it, and that's the model we've done. And then we've also set up a Lightning data module. So the idea is kind of you have a Lightning data module for data, and you have a Lightning model, like, Lightning module for the model. So that's it. And then we do the train. And this is pretty easy. We just do model and data module and trainer, and we do a tune and fit. So that's where we are right now. And what I want to add, yo, brother, what's up? We want to add tensorboard logging for loss, images, basically. We want to learn how that works so that we can see our training. I want to learn how to use callbacks a little bit better. Maybe we want to use, not early stopping, but yeah, we want to learn how to use callbacks. What I want to add specifically is, let's see, learning rate decay, learning rate scheduler would be nice to know. And yeah, maybe checkpointing, like continue from training. And yeah, that would be cool too. That would be Copilot's idea. Add more metrics via FID. This is the inception or is it Frecklet inception distance? Yeah. So let's do goals. Boom. If we do that, I'm real happy. Then I feel like we've gotten a really good start for Lightning. In just, I mean, I just did a stream 3 hours yesterday and today 3 hours. So that's not too bad. We're making progress. And then, like, what I would want to also know how to do is like how to integrate it with others, like Hugging Face, for example. If we do Yeah, thanks a lot for the kind words. I will continue on the path of trying to make useful videos that can help people learn faster, so that you don't have to make all these mistakes I'm doing on the stream. You know. But yeah, everybody is dumb in the beginning. So if I can just make good videos that can help someone learn faster, then I think that's useful. All right, so let's see. We are gonna now try to add tensorboard stuff. So that's probably the first thing. I mean, now we can train it, but we have no idea if it actually works. And you can see the loss here, but I mean, I don't know what this tells us, to be honest. We want to see like a graph, and we want to be able to print. Hopefully we want to use like a metric, like FID, for example, or I guess in this case, we would just want to log the images directly and see if it's making sense. So that's the goal. All right, let's go back to Safari. Where's Safari? Oh, well, that was a mistake. Okay, that's good. Tensorboard logging. Let's see. If that's the case, then that's pretty simple. Not gonna lie. Is that it? Okay, I don't think that's it. Is it? How does it work? PyTorch Lightning. What was it? Tensorboard, yeah, tensorboard.
Okay, so our model's been training for about 22 epochs now, and we can see here Lightning has saved a version of every single run that we had. So we're taking the last one, version 29, and we're going to be downloading that so that we can visualize it in TensorBoard. Yes, so our validation loss seems to be going down. The learning rate's a little bit dodgy, but I assume that's because of the scheduler. And what else? So let's see what our training loss is at the end of the epoch. So this is great. So generally over each epoch, it's decreasing well. 20, not even, how many epochs? 18 epochs.
As a dev dependency in your project, just file which contains.
All right, let's just read the docs. TensorBoard logger. Hopefully they print some information. Okay. Okay, so I guess this is how we do it. Self.log on the model. So we'll go back to the model. We'll add self.log to our training step here. So we'll do self.log train loss. I guess that's pretty much it right now. We can add some more stuff later, but this is okay. We don't have any accuracy or so here, so. Okay, so at least we didn't get an error, which is nice. And we can see, so on step, on epoch. All right, now's the question, just what's the point of this logger here? I mean, we have this logger and we've set it, and that's cool. And then how do we run it? So we do cd lightning ls my logs, I guess. So let's do tensor conda activate torch stable, and let's see, we'll do tensorboard log dir my logs. This is a problem. Okay, so we need to do a new terminal, and we need to SSH. Always forget how to do this. Let's try this. Now we should be able to open it here on another port. All right. And here we see, all right, so this is okay, I guess. I mean, we're making progress. So that's good. Now, that's nice actually. So this works. We would like to know, I guess it's done maybe? I'm not sure. No, okay. Yeah, so it's still running. This is cool. I appreciate the support. Karan, is that Karan? I'm not sure how to pronounce it. Sorry for butchering the pronunciation. So let's see. We need to know how to add images to our tensorboard logger. Logging images, lightning. Oh. There we go. Self.log tb images. Okay, that's cool. I mean, if that's how it works, then that's pretty easy. So we'll go to model, and we'll go to, let's see, the copy that, and boom. Oh wait, did I save it? Not sure. Let's see if this works. There we go. Ah, okay. Has no attribute log TV images. So this is not correct. Log TV images. What the hell is that? Hey Francesco. Nice to see you here as well. Yeah, I think I did the first stream yesterday. I was thinking this is it's not going to be clean. I'm just learning about this, but I'll make videos that are more refined later on, I think. Oh, okay. Oh, okay. That makes sense. So they it's not an internal. They created it here. So that makes sense. TB logger add image. And TB logger is where logger.experiment. I mean, that seems pretty clunky, not gonna lie. So you go through all the loggers and you check if it's a tensorboard logger, then you take it out and then you add image. Is there not an easier way than that? All right, let's just read about it. Lightning. It would be nice if they had an example. I could just check how they did it. Tensorboard. All right, so we define tensor and in a training step, add image. Yeah, that's what I want. Nice. So let's see if we can get that. Maybe we can just ask Copilot. Copilot, add logging of images to tensorboard X and X. No, I don't. Okay, maybe. Self.logger.experiment add image. I mean, yeah, you can do that actually. If that works, then that's pretty good. I mean, so you create a grid, right? I've done that before. And then self.logger.experiment. That's not what they did here though. Here they just add image. And here they did add image, generate multiple. So I don't know. I think we can keep this if it doesn't work. If it doesn't work, but here in the documentation they didn't do it this way. So Okay, let's just do this then. Self.logger.experiment. Oh, this is comment logger, I guess. No, it's not. MLflow. Oh, that's why I call it MLF. I was like, why is it called MLF? All right, this is what we want. Tensorboard add image, tensorboard logger. Yeah, tensorboard logger, fake images, add fake images. Let's just check that that works first. Nope. Come on. What? Tensor assert. Tensor. I'm using Mac OS for on my laptop, which is where I'm streaming from, and I'm using the machine is a Linux machine that I SSH into. I'm a bit confused here. So I just want to add images to the tensorboard, and we do tensorboard logger self-logger.experiment. We do add fake images, and here I'm just logging images, and I guess I don't understand how. That worked. I don't know. Let's see what happens. So we have image here. Cool. All right. That's nice. I would have liked to have a grid, but hey, I mean, maybe we can just do it the way they did it. I mean, Copilot did it. So let's try that. Copilot for the rescue. Okay, I think it's a lot. All right, cool. So we have reconstructed here. Nice. All right, let's go. PyTorch Lightning, baby. That's pretty cool, but our model is not that good. And I do think this is quite slow. I mean, I think it's like it's like 10%. I think this thing is taking a lot of goddamn time. So let's do if batch index. Yeah, modulus 100 or something. that's when we'll do it. What did Copilot want to do here? And I don't know. I'll just do this if batch index modules 100 is the case. Yeah, that's a lot faster. So let's rerun, reconstruct it here. Copilot is magic. Yes. The people that say that like don't use Copilot, I don't agree. I can understand the argument, but I don't agree in that I don't know, like it makes you a lot more productive, I feel like. I mean, it can introduce bugs. You shouldn't trust it just out of the box, but it can lead you the right direction, I feel like. Yeah, we're doing it. I guess the model here doesn't. Oh, what happened? Wait, what happened here? This looks so strange. All right, there we go. Yeah, the model doesn't really matter here, but we're doing a VAE. I've made a tutorial on this actually on the VAE, but this is just to convert it. Like all we don't really want to understand VAEs now. All we want to do is know how to convert things to PyTorch Lightning. So for that, we are adding to tensorboard now. So we want to understand integration. I do think our hyperparameters are probably a bit off, but at least we can see that it is reconstructing them. Maybe not the greatest, but it is working. So that's nice, and we do know how to do it now, so that's good. So the goal here is basically we want to learn how to do tensorboard logging, which is what we did now. I want to add a learning rate scheduler, and I'm also curious if we do, instead of doing it this way, we can do a tuner first, and then we do auto learning rate find, and then maybe that will help a little bit, and we can compare it. This is a setup I'm learning. It's tmux with NeoVim. Right, we need to add another tensorboard here, I think. This learning rate is probably fine initially, but it's not going to be the best after a while. So we need to add, I think, I mean, it is decreasing, but I do think we want to add a learning rate scheduler on this. right, so how do we, is that a callback maybe, I guess? Let's do schedule configuration. Yeah, it seems like a callback. So let's learn about callbacks then. Lightning. Oh, I don't know why, I don't like the intro on that. It's always so loud too.
Lightning has a technique to add arbitrary self-contained programs to your training, which are called callbacks. Callbacks is a general idea from computer science where during the flow of your code execution, you can plug into random places in that execution and execute arbitrary code. This means that you have full control over any point in the training system and can design self-contained programs that encapsulate a full set of functionalities on its own. The advantage of callbacks is that it decouples a lot of bespoke functionality that does not need to live in your Lightning module, nor your trainer, nor your data modules, and can be shared across other projects. For example, the early stopping and the model checkpoint are callbacks. With callbacks, you can do basically anything you can imagine. Use the callbacks argument to pass in a list of any callback that you want to use. You can design any callback that you want and add custom functionality using our callback API. There are over 40 different
Let's stop this. So we'll go to our model and configure optimizers. Here, I guess we will add here, reduce learning rate on decay. Let's see if Copilot understands that. So let's do add reduce learning rate on decay. There we go. Nice, it did. Okay, so it was the same. Cool. Nice. So we have scheduler and that, and I guess that's it. So we have patience 10, factor 0.5, and verbose. So we can go back to our train and we can add auto learning rate and and scheduler. Wait, this is the what's what here. So we have a name. We can still use the same my logs and then we can just change the name. Oh, okay, so I guess we need to add in our model maybe. This is weird. There's something wrong with my plugin, I think, because this is no syntax error, but it always happens with black, so it might be something wrong there. Right, okay, so it's looking at the val loss, and I guess that's going down. A bit unstable in the beginning, I guess. All right, it seems to be going down. And here maybe we should decrease the learning rate, I don't know. All right, reducing learning rate. Nice. That's nice. So hopefully it works. I don't like the pros. Obviously I'm forming my thoughts as I go, but if I would say like pros of PyTorch Lightning, I would say let's see what Copilot says. Okay, it's easy to use, it's easy to add tensorboard logging, it's easy to add learning rate scheduler, and it's easy to add checkpointing and continue from training. I think like number one is probably boilerplate code. Is already written for you. And then two, multi GPU, or like easy multi GPU. Those are probably the two main ones. Okay, so here we can see the difference, right? The gray one is without the scheduler and the blue one is with the scheduler. So it's improving. But if we look at this is step 0 though. I want to have it update. See, it's the same all the time. That's no good. Right? It's not changing. And we're running fast, so yeah, there's something wrong with that. The images are not correct. But it's definitely a lot better with the scheduler, so we'll keep it with that. And what we can do is let's go to that thing and see what's wrong. Well, we can print the batch index and see. Add 0, but we shouldn't add 0 there. Maybe it's can we go to this definition thing, logger, Yeah, I don't know what this 0 means here, because all I see here is 0 on the reconstructed stuff. So I'm thinking it's probably doing it once, which is not what we want. Oh, that's no good. I wanted to add all the goddamn time. I don't want to just have a single one. And I don't know why that's the case. I'm definitely confused. What if we go to images here? Still no? All right. Yeah, let's ask Copilot. So, but make sure, you see the progress pictures. No. Ah. Hey, Copilot, baby. Self with global step. Is that how you do it? Come on. If this works, I love Copilot if this works. No, it doesn't work. Fuck Copilot. Doesn't work. No, it does. It does. I'm sorry for saying that. I'm sorry for saying that, Copilot. You're the GOAT. Yay. Fucking yay, bruh. Let's go. That's awesome. Let's do if batch index modulus 100 equals 0. Move this inside, return the loss. Fix the syntax error. Boom, boom, no syntax errors. Do black, boom. Run it, bam. My logs and RM are my logs. Let's keep it with that maybe. My logs auto learning rate. So there we go. Now we got it probably working. So let's run it. Boom, we got a clean one. We got learning rate scheduler, which we saw helped us. This is weird. Sometimes it messes up my... Oh no. Oh no. What just happened? Let's try it again. Okay, no error, no error. Good, good, good. Yeah, I don't know what happened. There we go. All right. So let's remove this one from showing, and then we got it here. All right, cool. And we can see the val loss, how it looks like. Oh, that's not good. That is definitely not good. Might have started with too large learning rate because if we go here, nah, that's not too high, I think. All right, let's just have patience. Yeah, I'm a fan of Copilot. I like it. I know a lot of people are sort of unsure if to use it or not, because some people are like, yeah, it's like it's gonna basically make you like do mistakes and you're gonna lose the ability to code. But I don't know, I don't think so. Yeah, that's what we set up to set the learn rate automatically. That's what we did before, which is this thing right here. So what we want to do is we can do auto learning rate find. You can also do auto batch, select batch size, true. But I found some issues with that. So I'm not using this one. I'm only using learning rate find. And then we use the learning rate scheduler by doing... Actually, how did we do the scheduler? Yeah, we did it here, but I don't think you should do it here. I would rather have it... Well, okay. Here's where we set the scheduler now. I think it's kind of messy doing it all over the place, so I would rather just specify everything here and send it in, but I guess it works. And yeah, I mean, this seems to be working pretty nicely. We can see the loss is going down, val loss, and all of that stuff. So that's cool. What did we set the goals? So we wanted to do tensorboard logging. We wanted to learn rate scheduler. We want to do checkpointing, and we want to add a metric like FID distance. And then I think that's pretty good. Maybe also define h params, etc. in config file, and that would be nice to have it separate. So you go to the config file, you change all the stuff there, and then you just run the train, and that's it. So you have a good structured default setup. That's nice. Yeah, I don't think this is a very good setup right now. Like, the fact that we send in all of this stuff like this, it's okay that we have self-batch size here, but we should definitely not send this in here. And similarly for the model, we should send in learning rate outside. So we do like a, I mean, we can keep it in the train right now, but and we just send in the learner rate here. That's I think a better way. And then we later on we add all of these things, but we should also do, we should also send in the scheduler here. All right, what are we talking about? How often do you find yourself using pre-trained open source models? I mean, pretty much all the time. I feel like it's very rare that you're building a project and you're going to do it from scratch. You always sort of build from something and then you fine tune it. So very rarely I do anything from scratch that way. And resources on learning about deploying. Well, I'm not the best to ask on this. I'm just learning about that. But one thing I am learning about is Torch Serve. I like, it's pretty easy to set up. They have a good sort of handler on how you structure from pre-processing input to inference to post-processing using sort of a REST API. And I think it integrates well on deploying on like Amazon and stuff, or AVS. Probably it integrates on a lot of places, but that's for me right now what I'm learning about. But you know, the deployment world, you know, there's so much, and I'm just a beginner in that area, but is something that I'm gonna want, like I really want to learn about, because obviously what we're doing now is, if we're not deploying stuff, then what are we really doing? Because at the end of the day, we want things to be useful to other people, and we want to build things that can have an impact in some way. And for that, we can't just be playing around on our computer and sort of push it to GitHub. We actually need to learn how to do deployment and how to do all of that stuff. So I think that's more people should learn that for sure. All right, so what do we want to do now? It ran for 100 epochs. It's still going down, so you could have just... All right, so this is a good practice then. If we now have the checkpoint, because we do have it, we have it in my logs scheduler. I guess it's version 1. Version 1, checkpoint. Oh. It only saved once? That's a bit weird, I feel like. Oh, this is only the logs, right? So probably we have somewhere else. Because that's just the tensorboard logging, which... But no, that's a checkpoint. That's a checkpoint. So... Yeah, I'm not sure. Oh, I guess it saves at the end of this version, so... Yeah, I guess we can do this. If you want restore the full training, we can add that to the fit. So we can do checkpoint path is my log. Oh, there we go. My logs version scheduler auto learning rate VA version 1 checkpoint epoch 99 step 8600. We'll do 1,000 epochs then. If that works. Nice. And hopefully it continues with the learning rate we used. We'll see. And if it saves the global step as well, that would be cool. Yes, I think so. What? That is no good. How is it up there? That's a... What? 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 No, that's not good. It says restoring states from... What? It deleted it? Really? Okay, something's up. It should not delete my checkpoint. God damn it. That's strange. It just deleted my checkpoint and it ruined it. No. Oh, that's bad. That's bad. So we want to do it every... Ugh. Alright, let's just do default root directory. Oh, it might have been because we have a larger batch size, maybe that's why I changed the batch size. That could have been it. But it still should not remove the stuff. So I guess it's fine that every we want to know like how often should we save it. And this is a problem too. Yeah, okay, let's change this. So let's go. We'll go to model. We'll go down to this stuff and we will just that's probably better. So let's see how often it saves. So we have my checkpoint. Nothing. Okay, so now it's only saving at the end of our actual run. And we have my logs here. Scheduler. Version 0. Checkpoint. So now it's saving and overriding the last. I would have wanted to have I'm not sure what I would want, but I don't feel like it should be saving the model checkpoint at the logger direction. It should be default root directory, so my checkpoints. Default path when no logger. Okay, so okay, so this isn't used anyways, so we can just remove that then. If there are no, then this is used, so we can do my checkpoint, I guess, and then I mean, it's nice that it's doing sorry, let's see. ls my logs. Okay, so it's nice that it's saving at the end. That's a good thing, at least. But we definitely wanted to save in some smarter way as well. We want to have some backup, I feel like. What if just it gets destroyed for some reason? So we have model checkpoint by monitoring a quantity. Maybe we can add this, so we can try to do this. Or let's ask Copilot. So fix or add a callback for not learning rate scheduler, but add callback for this thing, for model checkpoint on Valos. Yeah, I'm using yeah, I'm also learning. I'm learning NeoVim and I'm learning about PyTorch Lightning, kind of both at the same time. And I'm using Copilot. Yeah. So let's see. Hopefully it did. Let's see. My checkpoint. Oh. All right. It's saving it in my checkpoint now. So scheduler C version 0. And then checkpoints. All right. And we have last and we have, okay, that's pretty cool. All right. So let's see if this works. So we'll do also, we'll continue from the last one. From checkpoints. If we do that again, we'll do last dot. Oh, damn it. Like that. And hopefully it should continue from that point. So if we just stop training at some point, it'll continue. I don't know if it's doing the right thing. I don't think so. Because their path has changed. Okay, let's see what happened. Oh. This is okay now. Clear ls. Version 1. All right, so we have version 1 here. And last, but what if we stop it and then we do version 1? Oh, I know why. So we need to do tensorboard my checkpoint. There we go. Right, now we're also doing the learning rate, so we can see that. We have the original and we have the reconstructed here, which is diverged or something. All right, okay, we have everything now. Let's remove that. All right, so we have everything. We'll remove my logs as well. And now we should hopefully have everything to just run it. We're specifying the batch size. We're doing auto learning rate find. We have our callbacks, which we're monitoring the learning rate, auto checkpoint, tune, and then we just fit on it. So oh, okay. All right, so if we don't have a checkpoint path, we'll just do this. Thanks for joining, Zita. Appreciate the kind words. It might be great to see export of model on AI device like Google Coral, Orange AI Stick, or Orange Pi 5. Yeah, I don't know about those actually. Is that like a Raspberry Pi kind of? Like a Jetson, what are they called? NVIDIA Jetson? Yeah, Jetson. Yeah, that would be cool. Oh, it's a USB stick. I was thinking, yeah, I mean, like me doing this is kind of messy, and I'm hoping that people see that, you know, there's a lot of mistakes, and, you know, there's now the goal is just to learn about Lightning, but I was thinking in the future we could do some kind of project, some cool open source project of some kind, where we would focus on, you know, trying to actually deploy it, make it available, that I think that would be pretty exciting. But right now I'm just focusing on getting more comfortable streaming because I'm not used to it. And I feel like sometimes you get kind of nervous streaming, so your thought processes are not the same because you now feel that people are watching or something. So I think it's like a habit to get into. But it would be fun to build open source projects and deploy them. I think that would be exciting. I mean, this is working, but it's not that good, to be honest. I mean, it's plateauing now too. Learning rate. Yeah, learning rate is super low. I feel like it probably reduced too quickly, right? I mean, or not. I guess this is good. But this end result is not the greatest, to be honest. And I'm not sure if one would actually want to have this large of a batch size. I felt like we tried like 32 or something and it was like a lot better. So maybe we can try it again, see if it's a difference. But now it's just optimizing this, I feel like, so it's not that important. We've done, we want to learn how to do metrics, and then we want to change our structure so we define the H params in a separate config file. I feel like that would be a lot cleaner. And other than that, I think it's looking pretty good. I feel like we've learned a lot about Lightning, and maybe we should just take a look at the docs a little bit more, watch some videos or something, and get a better understanding of it. Stream next time? I'm not sure. I think probably, I don't know, like now I was like, all right, I learned Lightning, and then I just learned about it first time yesterday, and then I was like, all right, but now whenever I'm learning about Lightning, I'll just stream it so people can follow the process if they want. And I was thinking of setting up like after I have a good understanding of it, I will set up some type of structure, maybe like, I don't know, 10 videos or something. Depends on exactly what could be a good structure for it, but like 10 videos showing like step by step how you could how to use Lightning and the pros and the cons, and explain why one wants to learn it and how to use it. And welcome to the party, Jesus. All right, let's see. I don't know. What should we do next? I feel like now it's pretty good. Like we've done tensorboard, learn rate scheduler, checkpointing. We haven't done metrics or this though, so maybe this is next. I feel like this is probably the next step. How to do a config file and set up everything there. Because now we have, or maybe just use a callback for the thing. So we'll do model, and we'll remove scheduler from here. I don't think this should be inside here anyways. can ask Copilot, maybe. Add, let's see, we want to call back for, add a callback for learning rate monitor, model checkpointing, not early stopping, and scheduler on plateau. Maybe there is no, I don't know. I need to change my Vim mapping. Sometimes it doesn't generate if it's not sure, but you can force it to generate, but I don't have the key map to it. Maybe we can force it like this. There we go. All right, so we have patience 3. I don't remember what I used for this. Maybe we can increase the patience a little bit, and we can do a min learning rate and the mode, and that's pretty good. So that way we have everything here, and I feel like that's okay. Maybe, I don't know what a good setup is. We can have it like this. Everything is defined in the train, but if you scale it, I think you would want to have a config file. And I think this could be at the top. And then we can also, like, num workers should also be here. We can do, I don't know, like 8 maybe. So you can set for the val, I guess you could, let's try that first. So we just do num self.numWorkers on everything. Self.numWorkers. And then self.numWorkers is numWorkers. And we send in numWorkers. Okay, that's better. I don't know what else to do. Yeah, I think we're done with this. I'll skip doing it in the config file, and then metrics, I don't know. We can maybe look at that, but I don't think it's that important. Okay, here we can see the learning rate dropping. Yeah, I mean, I don't think we're expecting too great results, so I think this is fine. And this seems to work pretty nicely, so. Oh. Okay, this is one problem with with Copilot. Like sometimes it just writes stuff that doesn't exist. So lightning reduce learning rate on plateau, callback. Reduce learning rate on plateau. So they do it here. So they do it there, but that's not really, I don't like that too much, because I want to set it up. If I want to change it, then I want to do it in the train file or a config file. I don't want to move all the way to that again. How do you start learning a new framework or programming language? I don't know if I'm the best to answer that question, but Like for programming languages, I haven't learned. I basically just use Python. But for frameworks and stuff, I think usually, I mean, the fastest way is to just go through the documentation if they're good, like they seem to be for Lightning, and then at the same time you're going through it, just try to use it. So what I'm trying to do here is I'm getting an idea of like, okay, that's how it works, and then I'm moving into my project, implementing it to see that everything works. So it's sort of a getting practice with it. And I would think it's the same for a programming language. It's cool to get ideas from documentation and so on, but make sure you are trying it out real time and doing your own experimentation. Yeah, it makes sense. So let's remove this. I don't know how to include the learning rate scheduler though. I mean, we can do it as we did before, but it would be nicer to have it. It would be nicer to have it separate. So yeah, we can maybe. Maybe we can check out some videos or something. So now, for example, I've done sort of a lot myself, building stuff. So now I feel like it's good to have like a mixture of getting information in, sort of inspiration, and then doing stuff yourself. So.
Hey everyone, I'm William Falcon. I'm the creator of PyTorch Lightning and the co-founder of Grid AI.
So this is cool, right? This is okay, never mind. I actually,
and along with Sean,
I want to know how to do multi-GPU training, right? This is the idea, is that we can just do this now, and we should have, if it runs, but we should have, let's see. Okay, so we're running it now, and then if we just do GPUs 2, we should have it on multi-GPU training. And then the idea is, fuck, it doesn't work. All right, this is the pro of PyTorch Lightning, if it works. Not sure why it's not working. Oh, multi-processing spawn. It has to do with the non-workers, I guess. Let's do 0 for fun. See if it works. Nope. Okay, it wasn't that. Oh, it's trainer.tune. Okay. So we'll do trainer.tune on a single GPU, I guess. And then for multi-GPU, you set only the fit. Yeah. Okay, cool. Not sure why it's so slow though. Sync dist true when logging to accumulate the metric across devices. All right. Find unused parameters, but did not find any unused in the forward pass. If your model indeed never has any unused in the forward, consider turning this flag off. All right, so let's do sync and also persistent workers. Maybe that's a good default. I'm not sure. I haven't used that so much. And this is looking ugly, so let's format the code. Bam, done. So we got persistent workers, that, and then what do we want? We wanted to sync something over where? In the model image. That's my idea. So I don't know how it's doing the multiple GPU training now. I know that there are multiple strategies you can use, and I would like to learn how to specify exactly which strategy we want, either to copy the model on multiple, which is the data parallel, I guess, or if you want to, if you actually want to split the model on, like split the parameters of the model if you're running a really large one. That's actually like one of the big motivations for me for wanting to learn about PyTorch Lightning. So I really hope that it's easy, because that's sort of what I'm expecting. What happened now? We did set persistent. Come on, we did do that, right? Data set persistent workers. Is there one more? Ah, we didn't do it for a training one. All right, we'll continue then. So Python train. Okay, cool. I don't know if that's what it's doing exactly. Maybe we can look. All right, so it seems to be doing the data distributed parallel. So it's running the model copied onto both of the devices, and then it's just running the data through it, I guess. So yeah, I mean, we want to specify that strategy. If we go down to the trainer here, DDP maybe, or multi-GPU, or GPU. Strategy. I feel like it's the strategy. Supports different training strategy with aliases with different. We can go check maybe. PyTorch Lightning. Like, I don't know, one is called zero strategy. Is it called zero? I think it's called zero. Zero redundancy optimizer. Or maybe I'm confusing something. Here we go. Oh, okay. So you do. Oh, okay. So you use deep speed in the strategy, or this. Can we just do that? Does that work? If that's the case, then I'm such a big fan of. So we do strategy, DDP. We can try that first. I guess that's the default. This was a lot faster, wasn't it? This was a lot faster, no? Look, 190 iterations per second. And then if we go NVIDIA SMI, it's using both. And then if we remove the strategy and we do this, let's see what we get. Yeah, see the difference? 190 to 50. Oh, okay, it was only the first epoch. Ah, okay, that makes sense. I was like, how did we get 6 times improvement from changing the strategy there? Yeah. Yeah, that's a good idea. We can try... I don't know exactly how we... I mean, one thing we can do is check just the speed, maybe, the iterations per second. We had... Oh, it's faster on a single GPU. Yeah, it's faster on a single. I mean, we're not limiting it in... I mean, it's like... I think there might be something... We might be limited by something else. But yeah, in this case, it seems that we are not limited by the GPU, maybe by the data loading in or something. We can check maybe profile simple, and we can see what we're limited by. Okay, wait. I was expecting to get... Let's do just one epoch and we can see. All right, so percentage of time, run training epoch 64, run training batch, valuation optimizer, DDPS spawn strategy backward training step. Okay, so I guess some of the time now is... So it's mostly using the time for training, but some of the time is taken for optimizer step and strategy backward and step. So I guess maybe it needs to do some, yeah, I don't know. If we do devices 1, maybe it's not limited by, I mean, it doesn't have to do these DDP spawn stuff. So I guess that would make sense. Oh, but no. So wait. Okay, wait. So here, I did a mistake, I think. So if you look here, now it's going to run through the entire thing, right? So this is one epoch, and we get 230, right, iterations per second, but we have 1.8 thousand batches. If we do devices 2, then yeah, we're going to be limited a little bit by the data loading. But if you look at, the number of batches now, it's halved, right? But the iterations per second is, okay, well, before it was, I guess this is for the num workers, right? Yeah, this is for the num workers. So if we do multiple, look, if you do multiple epochs here, it's going to be a lot faster for the second epoch because of the num workers getting started. And then you'll see that it's a lot faster for the total, going through the entire data set. But the iterations per second will be slower, obviously, because now we're going through, so here it's 40, but then next epoch, boom, 180, 190. But remember that we're now going through the entire in 900 batches instead. So we're losing about 30 iterations per second, but we're going through the entire data set. So no, devices equals 2 definitely helps. That's that makes sense. So that's good. And you know, we wanted to do this strategy thing. I don't know if we do like deep speed, what happens. Let's try it. Let's try it. FSDP as well. I have oh, all right, pip install u. Can I just do pip install deep speed? All right, deep speed, let's go. I'm so, like, I have no idea what I'm doing. Like, what did we just change? Does anyone know? Let's go. We're just using deep speed. We have no idea what it does. Yeah, all right. It's slower, right? It's a lot slower. I don't know what the difference is. But it is slower. And now it's using more. I'm confused. Deep speed was a lot slower than DDP. So yeah, I guess you could increase the batch size to that could be a good idea, but deep speed was a lot slower. I'm not sure what it does exactly. Maybe we should just take a step back and just listen to the guy, learn what we're actually doing. Oh, goddamn. All right, let's remove those. There we go. There we go. And then let's remove those. Hey, Philip. I'm doing all right. I'm getting a little bit slow though. It's been a good day though. It's been productive. I feel like I have a lot better, a solid understanding now, or a better understanding than I had this morning. So that's good. I don't know what the time is. It's almost 4. So yeah, I think now we could just check out. Let's see what the goal is now, because now we've done all this stuff I actually wanted to do. I think we want to know how to do the scheduler in a better way. Maybe send in the scheduler and what to monitor. But I feel like a lot of those things we could learn just automatically by reading a little bit more. So instead of trying to figure it out ourselves, we can just read a little bit, see some videos on how people are doing it, and then we will have an easier time probably. So that's an idea that I have. And yeah, so the strat, let's do some goals, or like what we would want to learn. So goals now is, let's see. What are our goals? Understand the strategy, deep speed versus FF, what was it? FSS, I don't know, that's deep speed, etc. DDP versus etc. That's the goal. And what else? No, set up a config or oh, that's a good goal. And then metrics, maybe metrics, and I think those are pretty good. And then maybe do like a complete sort of project thing, that where we can do the custom data set and all of that stuff. That would probably be a good idea. So yeah. And I haven't checked out what other people have done, but there might be good resources for learning about this. I know they've done a lot of videos, so might be some useful ones here.
And the final principle is full flexibility. So I had been using many machine learning frameworks for
GPUs, and this allowed them to reach state-of-the-art results in speech-to-text, makes sense, and opens up the possibility for larger models. This diagram was taken from a recent paper around mixture of experts, scaling to a ridiculous 1 trillion parameters. And at this scale, you really have to consider splitting your model. Just imagine the amount of weights that need to be stored and iterated through the training process. Now let's delve a little bit deeper into what these ways are possible in this field. Applicability, something a little bit smart and store intermediate states, also sit on top of your memory usage. And now we see a complete view of why our model, or our large model, cannot train on one GPU, as there's all these other things that need to be allocated. So instead of duplicating everything, or the model, onto every single GPU, a solution to this problem may be, can we partition the model onto every single GPU, if we like, even the activations? This does come with a larger communication. As you can see, we just set the accelerator flag to DDP and the number of GPUs and number of nodes. This will automatically spin up any processes that are required and handle any of the orchestration for you, so you don't have to worry about anything or any changes required for your model or your dataset. For sharded training, we've worked very hard to make sure that we have the most seamless and easy to use
That was cool. I don't know what it did, but Let's do 10 epochs. Let's run it and let's understand what it does. All right, so this is sharded training, meaning it doesn't replicate the model on both. So I guess so now we've split the model. I don't know. This is what next thing we're gonna learn about. So we can see that if we do strategy DDP, we can compare it. But hopefully that's what it does. That's anyways the goal. And you saw how easy that was, by the way. I have no idea what I'm doing, but as you saw, it's like one command to change it. So before it took, this is actually taking less. I don't know. I feel like sharded should use more or should use less. So this is doing data parallel, showing. Okay, so I mean this is doing data parallel. What's the difference with sharded? Yeah, I guess this is need to take some time and just look at this. Fully sharded.
Keep an eye out on the PyTorch multiple models.
PyTorch Lightning DDP plus sharded.
From scale up these model sizes. One thing to
yeah, that's a good idea. I guess we remove this then, so let's see. Okay, 400 megabyte. I'm confused. I don't know how that works actually. We will spend some time learning that. I think I will take a break for today. It's been a long, but it's been productive today, which is good, so I'm happy. I think honestly I'll continue from this. So this is where if you'll join the stream tomorrow, I think I'm gonna stream tomorrow, and then we will continue from this. So I'll continue from this video and then try to see how it works, the strategy thing, what to use basically, and learn which one is the go-to and maybe a little bit how they work. Then I'm starting to get then I'm feeling like we have a proper setup. Maybe learn how to set up the config, a little bit about metrics, maybe a little bit more about let's see, it would be cool to know. Actually, I'm unsure what else. So yeah, I guess just those. So it's been good. Today we've learned how to set up the data module, all that stuff. There's a lot. Tensorboard, checkpointing, callbacks, auto learning rate finder, auto batch finder, a little bit about multiple GPU training.tune, overfit batches, how to structure it and all of that. So it's been really good. All right, thanks for watching, guys. Hope you enjoyed a little bit of the stream. And again, I will I understand if people don't have time or want to watch me do all the mistakes and stuff. So if you're interested about learning at PyTorch Lightning, my goal is to make separate tutorials that are more condensed, more refined, but that will happen when I feel comfortable and that I have a good solid understanding of what's actually going on. All right, I'll end the stream here. Thanks for watching, guys, and I hope you have a great day. See you tomorrow if you join the stream.